All right, good morning and welcome to our study on space and astronomy, Chapter 1, Lesson 1. So this is a short few pages, but there's a lot of information I would like to cover with you as we get into our astronomy study. Once again, not everything in this book, and it is a smaller book, but not everything in it is going to be fifth and sixth grade topics. So we're going to hit all the things that we need to before we get into our next book, which will be on forces. Just a reminder, make sure you're taking notes, highlight in your book. One of the bad things about several of these sections in the book is it's black background. So I would strongly suggest that you have a notebook or at least a sheet of notebook paper to take your notes on. There will be a test over chapter 1, and part of your test will be over the scientific method, which we just went over. So we're going to start with page 5, where we start looking at the basic terms that we're going to be studying throughout the book. The first one is the idea of planet. So on the first page, we can see in our book, we're talking about this guy who recorded information. He's from India. So when it says he's an Indian, it does not mean he is a Native American in North America. It means that he is actually from India, over across the big pond connected to the Asian continent. But in the early AD era, he recorded information about stars, constellations, moons reflecting sunlight, and things like that. So we can see early on that people were studying space and they were once again asking those basic questions. Greek astronomers recorded their studies and the things that they did. And it's actually the Greek astronomers that give us the terminology of planet. So basically, what was happening is they were following the steps to the scientific method. They were going through and they were asking the question. As they were studying the stars and plotting constellations and creating pictures out of the stars, they noticed that there were a couple that seemed to be moving. Now, it wasn't one of those things that they were flying through the sky, but as they were charting the constellations and creating their images up in the sky, such as Orion, then they realized there was a couple of those stars that would move every few days, and they began to wonder why those were moving and nothing else was. Right? So they made an inference with all the other constellations, all those other bright dots, those stars out in the night sky, they were staying still. And yet they could track three, four, sometimes five different stars that seemed to be moving over time. So they made a hypothesis. They thought that they were actually moving. Now, the step in the scientific method that they could not do was the research because they didn't have research back then, right? The Greeks were the original astronomers of recorded history. So any research they had would have come from that local group. And so there wasn't a lot of information at that time. So they skipped the research step, but they did a test and they began to track and they began to draw their images in their notes and keep track of certain ones that were indeed traveling. And when they compared their notes, every constellation stayed the same, except for three or four little stars that seemed to constantly moving throughout the sky. So they concluded that they weren't necessarily stars, that those must be wanderers, and our word for wanderers in the American translation is the word planet. So when we talk about planets, we're talking about wanderers in the night sky. When we look at the stars, they're in a specific location. They don't change, but it's so on page 5, we have our 5 different text boxes that we can look at with all sorts of information, and I'll add a little bit of extra information for you as well. So if you would, please take your notes. Once again, there's not a lot of space here to take notes, so get some notebook paper or a tablet, take some notes because this stuff is going to be on your test. You also need to know it for your assignment, right? So we'll start with planets, talk about moons, and then mention meteors and comets, and then we'll spend some more time on stars as we get into pages 5 and 6. But once again, as in all of our books we've done so far. Chapter 1, Lesson 1 is really an introduction of all the information we're going to cover as we go through the book. So as we start with planets, then we look at our particular solar system, right? So in the middle, we do have a star. It is what we call our sun. And we should know by now that we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. We do have our dwarf planets. We have one that's close to us called Ceres, but outside in the further away orbits, then we have Pluto and Haumea, Mackay, Eris, and then we have a few others out there that have not officially been adopted with their names. But we're going to talk about how planets are planets because they follow some specific rules. First and foremost, they're going to orbit around a sun. An orbit, which we'll get into some of these more scientific terms later on as we get into our book, but it just simply means a specific path that travels around the sun. It's often seen like in this picture as circles, but they're really not circles. They're really in a more of an oval shape. But when we look at the idea of what the planet is, then by definition, it has to be rounded, right? So when we say round, it's not a circle, it's actually a three-dimensional circle. So they are a sphere. And one of the things about its sphere is that it's going to cause a gravity on it. Now, some of our planets, when we study them, they're going to have a really high impact gravity. Some basically don't have much of a gravity at all. But because they are round, they spin on their axis, they're going to have a gravity. Its orbit, then, it must be clear of other objects, meaning that as it travels around the sun in its set path, it's not hitting other planets. It's not, knocking other things out of the way. So when we look at that orbit, then, it's just the path that we travel around. So when we talk about things like Jupiter in that image, then Jupiter is going around. If I would be looking down from the top of the sun, it's going around in a counterclockwise direction. In fact, when we study all of our planets, other than one very stubborn one, they all go in a counterclockwise direction. There's only one planet, and it's the only female planet that we have that goes in a clockwise direction. So it could be that either because the female is stubborn or maybe she's the only one doing it the right way. But no matter what, they're all traveling around the sun in a set path, and there's nothing else in their path that would cause any problems. So when we look at our planets, then we can see that from Earth, where you and I are standing, throughout different times of the evening, from dusk until dawn, we can see 5 different planets from Earth. I don't need a satellite to be able to see them. I just have to know where I'm looking, right? So when we're in the new moon phase, we can actually see Mercury up in the sky early on in the evening. We can see Venus, we can see Mars, we can see Jupiter, and we can see Saturn if we know where we're looking, right? I don't need a telescope. So for many, many centuries, multiple generations before the year 1, so we're talking about BC also, people knew that there were planets out in our solar system, but they also knew there were 5 of them, and that there was only 5 of them. Okay. So then when we talk about satellites, I'm going to add a word to this word satellite because we will later on, as we finish up this book, we'll talk about artificial satellites, man-made satellites. So the word satellite, when we're talking about natural satellites, is what we would call a moon, right? So we have just that basic terminology of moon, but scientifically, they are referred to as satellites. And a satellite is an object that orbits a planet, right? So planets orbit a sun, and then sometimes planets are going to have something that orbits them, and then it could be a moon or multiple moons, right? We know Earth has one moon. When I look at Mercury and Venus, they don't have a moon. Our very next planet, though, Mars, we start seeing multiple moons. Mars actually has 2 moons. They're much smaller than our moon, but it does have 2 moons. But then when I get outside of the asteroid belt and I get to Jupiter, Jupiter has over 60 moons. right? Some very large, some very small. But when I get to those gas giants, they all have multiple moons. Even Pluto, our smallest planet, way out in the Kuiper Belt, it has multiple moons. So once again, a moon, it's just a natural satellite that orbits a planet. That third box then talks about meteors and comets. Once again, this is a section later on in the book. So this is a brief introduction, right? What we call a meteor, we often call in general terms a falling star, that streak of light that's in that image, right? When we get into that study, we actually are going to figure out and learn that there are three different terms used for this space rock. It's either a meteor, or excuse me, a meteoroid, a meteor, or a meteorite. So that's just a brief introduction to what we will get to. Then we'll also, at that time, talk about comets. And comets, like the most popular one would be Halley's Comet, but it's just a large collection of dust and ice that will have a large oval journey around the sun. And some of those comets, as NASA has tracked them, they have an orbit that takes 600, 700 years before it goes all the way around. So some of those things people have seen fly by the Earth and then they've never seen it again in their entire lifetime. So then we need to know what a star is, and that's really what the next few pages are going to talk about when it comes to stars. So when I look at all the stars and I go outside and I'm looking up into the night sky, right? It's truly just a giant ball of extremely hot gases, right? So nuclear fusion is happening. And what nuclear fusion is we have the most basic, smallest element, hydrogen. And they're, because of the force, the size of these suns, the gravity is pulling them all together and forcing them to combine and create helium. Well, that causes an explosion, right? So nuclear fusion is when I force things together, right? When I force things together, we have a large explosion, two hydrogen atoms coming together, being forced to create helium causes this massive explosion. There's also nuclear fission, where I can take an atom and pull it apart, which will also cause an explosion. That's what things like the atomic bombs are made out of. But when I have this large, giant area of these gases constantly being pulled together and exploding and creating helium, that's when we get a star. And once again, our sun is just a star. It's the closest star that we have to our planet and our particular solar system. So all of these explosions are happening. These explosions then give us two benefits. We get the light from the sun. We also get the warmth or the heat from the sun, known as thermal energy. But stars, every star that you see out there in the night sky, it's just a giant ball of burning, flaming gas. You just don't know how far they are. When people were studying stars, then they started looking at constellations. So what a constellation is they take a set of stars and they create an image out of it. I would say probably in our area, the three most popular would be the Big Dipper, the Little Dipper, and Orion, because people can often find Orion's belt. It's three stars that are directly connected in a straight line. So when I look up in the night sky, though, I see all of these constellations that we can see that make up these pictures. The thing is with our constellations, we often look at them according to the Greek um, astronomers and what they had decided that they were. It's why we have Orion's belt, right? Because Orion was one of their demigods that they used to study. So this is the constellation for Orion's belt. But in every culture that has ever studied the stars, they're represented on the outside circles. They use those exact same three stars and they see a different image, right? So depending on where you were, depending on your culture, as you're looking at the night sky, you're seeing the same stars in the northern hemisphere. However, you might have a different term for it. You might see a different individual for it, right? Even the Native Americans, as you can see basically in the bottom left corner of this image, they had studied the stars, but they looked at them as different individuals or different items as well. So constellations are just the pictures that we get by looking at the stars. In your book, you'll see that I believe there's a bird. You can see the bear, which is Ursa Major. Part of Ursa Major is what we refer to as the Big Dipper and the Little Dipper, right? So when I look at these, then I can see that we have available to us something called a sky chart. So the star chart is here's what the northern hemisphere sky looks like, and you can pick them according to your culture, and then it'll show you where during seasons these constellations are located, right? So for example, here's two different or star charts because they're for two different seasons, right? So when I look down here in the bottom east, um, bottom right corner, then as time is going along, then our constellations are going to seem to turn in the night sky. Well, they're not actually turning. It's just because the Earth is traveling around the sun, and with our orbit and our tilt, it makes it look like the constellations are moving. But the constellations are always going to stay in the same location. It's us that changes, right? So as we are traveling counterclockwise around the sun, it appears that they're going to be moving clockwise in our sky. So the way that works is, excuse me, if I would be walking along and I see an eagle up in the sky, right? I can walk around and look up, and it would appear that the eagle is traveling around, but it's actually us. It's the same idea with constellations. As I look up in the sky and my Earth is traveling around, it appears that those stars are changing, but they're actually not. They're always going to be in their location. So when we talk about our traveling around, when we talk about our orbit and our revolution around the sun, then it causes several different things for us, right? So we get our seasons because of our journey around the sun. Right now we're in the winter. Notice the image of the Earth, it's on a tilt. We will talk about our axis and our tilt and the direction that it always tilts. We'll talk about some specific terms, which I've introduced to you already, but we'll talk about the solstice and we'll talk about the equinox and when they happen. But right now we're in winter, right? So as we travel around, our seasons are going to change. So as we're in winter, then we just got finished with January, right? And now we're heading into February. So in relationship to the sun, if this was our orbit, then this is where our Earth currently is, right in the middle of January and February in their journeys. So each of the dots is represented, I believe, by the 22nd of the month. According to counting by the calendar, then that's when we get our solstice and equinox. So in the winter months, then we're going to eventually get into spring, which happens on March 21st, March 22nd, right? So we're going to be directly across from the sun. And then for 3 months, we travel in springtime. So we go through March, we go through April, we go through May until we're directly across from the sun. That's officially when summer is going to begin. So our summer begins in June, and then we have 3 months there. So we're going to have June, July, and August until temperatures begin to slowly drop because it's going to start getting cooler because we're now directly across from the sun, um, and our days are going to get shorter. So fall begins in the middle of September. We go to October, November, December. A lot of people think that December is winter. Well, up until December 22nd, it's fall. Winter doesn't actually begin until December 22nd. So notice that in this journey all the way around, we've got 3 months, 3 months, 3 months, 3 months. So it's divided into quarters, and 4 groups of 3 is what gives us our 12 months in a year. Okay? So when we talk about our planet's motion, then we discover that there's this thing called a zodiac. Now, some people know there's zodiac signs, such as my birthday is April 3rd, so I'm an Aries. Some people are Cancers, or um, I don't know what all of them are. I'm not a zodiac person, but we're not talking about the zodiac sign. We're talking about a path, excuse me, that our planets travel through. So, Earth, Mars, Venus, Jupiter, Mercury, Saturn, all of those planets are going to pass through a specific location in the night sky as we're watching them and tracking them. So that's just what the zodiac is, as the book mentions it. That might be an assignment question. So finally, as we end up and finish with chapter 1, lesson 1, I want to leave you with what is referred to as an interesting factoid, something that several people don't necessarily understand. Right. So when um, dusk is beginning to set, we have our first star that we see. A lot of people, I know when I was a kid, we would wish upon the star, right? Starlight, star bright, first star I see tonight. I wish I may, I wish I might, I wish upon the star tonight. And I would get so frustrated and upset because my wishes very seldom ever came true. Well, I found out when I got into science why that is. Because that first star is not a star, that's a planet. The first, what we think is a star that we often see every night, is actually the planet Venus. It is so close, and its atmosphere is full of pretty thick clouds that it reflects the sunlight so brightly that we can start to see it as the sun is going down. So that's actually a bright and morning planet. So it wouldn't have done you any good to make any wishes on it. All right, so that would be most of a class period and the information to give. Please take your notes so that when you come back into class, you'll be able to do your assignment and not have any problems.